Hello and welcome. My name is Elliot and I'm one of the developers along with Aaron, Francisco and James which built the app Choremaster. Choremaster is a mobile game designed in order to gamify the distribution and completion of chores in a household, just to make doing them a bit more fun. Let's take a look at a demo. On opening the app, users will be asked to log in or create an account and then create or join a house. If you create a house, other users can type in the house name in order to join and show up in the lobby in real time. Once all your house members have joined, you'll be prompted to list a group of chores which are shared between the household. Then you will assign them a point value of 1, 2 or 3. The harder the chore, the more points it should get. Once this is done, you'll be redirected to the game screen. Here users will be given a random collection of chores and some wildcards. Wildcards allow users to swap the chores they have with other players. Each wildcard has a different effect. For example, the swap wildcard allows you to choose one of your chores and swap with a random chore of another player's. And the shuffle wildcard will redistribute all the chores. The game ends when all the users have either pressed done or used all their wildcards. A home screen will then be shown which contains the tasks you had when the game ended. These tasks can be completed in exchange for points, which can be spent on wildcards to be used in the next game. The game restarts in a week's time, but whilst you're waiting, feel free to read the descriptions of each wildcard in the Your Wildcard screen, or see how many points your rival players have in the leaderboard. Now I'll pass over to James for an overview of our tech stack.
For the front end, as our app was working in real time and would be refreshing constantly, our main aim was to find frameworks that would support this. We also needed our app to work on mobiles, as the users will be looking at their updates together from different views at the same time. For login, Firebase Authentication was used, as it's secure and users can sign in with a system they already trust. This saved the project time by not having to develop a more complex method of signing in. For our front end, we went with React Native, as we were designing our project for mobile platforms. We found this to be the best choice, combining JavaScript and native API development. Another noted feature is that React Native creates code that works on both Android and iOS platforms and comes with a lot of native APIs out of the box. This makes adding native features to the app easy. React Stack Navigation was used as an efficient way to travel backwards and forwards through the app. We also imported the modal library to create stylish pop-ups to explain the rules to users without having to send them to another page. To enhance React, we included the Expo framework in our front end. This choice was made as with Expo, it's easy to use and install on mobile devices and can update in real time, which was great for testing the app on the fly. Finally, in the design phase, we decided we wanted vibrant colours that would inspire people to clean, so a citrus orange background paired together with a cool complementary blue created the framework for our app's balanced and stylish look. I will now hand over to Aaron to talk about the back-end tech choices.
For the back end of our tech stack, we had a number of requirements. Due to the multiplayer aspect, we required a real-time database hosted online. We also required a way to implement authorization for a login process to allow individual users to be identified and their data safely stored. To meet these requirements, we selected Google's Cloud Firestore, a cloud-based NoSQL database. Although we considered using our previous experience with PSQL and hosting on Heroku, after spiking out Firestore, we came to the conclusion that it offered more ready-made functionalities, such as real-time listeners and authentication through Firebase. Firestore is a non-relational database that stores data in collections of documents, a format not too dissimilar to JSON. After testing out a few approaches, we came to the schema shown, allowing us to access, set, and update data on different users, the houses they are in, the tasks they have been assigned, and the wildcards they own. In addition, Firebase comes with authentication, saving us the time required building that ourselves, and avoiding concerns about data security. To access this data, we set up a number of functions that would take user input and write it through an API call. For our real-time data requirements, we were able to monitor the state of the database and broadcast changes to users when our data met certain criteria. Primarily, this was used for monitoring the lobby as users joined a house, and for gameplay to show the effects of other players' actions. I'll now hand over to Francisco to cover the challenges we faced.
Hello everyone. Our initial challenge was to create a project learning as much new technology as possible. And this has motivated us to confront many challenges. In our front end, React Native Expo is very similar to its brother React, and this has helped us to understand it. But we find it in many ways different in its styling and usage. For example, making a dynamic image was one of the biggest challenges we faced with this technology. React navigation was also very different to any other previous routine that we have used before. We had to learn how to create a nested navigation with two different stacks out of main in order to allow us to pass a logo button in the header and achieve a persistent login. In our backend, Cloud Firestore was definitely one of the biggest challenges. We had to learn about non-SQL database structures. And in particular, we learned that Firestore behaves differently to JavaScript with arrays. As Firestore doesn't allow you to initialize an empty array. Arrays has to be initialized with a placeholder element inside of them. Also, in testing, we learned how to use a third-party library called tsmock Firebase in order to test our web API's functions. And how did we approach these challenges? We had to research code bases on the internet, reading documentation, working collaboratively, using agile techniques, and working with so much determination. Thanks for watching Choremaster presentation.